So we're going to take a look at just a few applied problems as to where this idea of symmetry can come in. And let's say just for some reason that we have a function f and it's an even function, okay? And we know that from -8 to +8 of f of x dx equals 8. Okay, so what we'd like to do is we'd like to find what it means to go from 0 to 8. Okay, so here's what we can do. Remember that if a function is even, okay, then what we can say is that the integral from -a to a of f of x dx is equal to twice the integral from 0 to a of f of x dx. Right? And so what that means is if this is 8 is equal to twice the integral, right? So we could just say 8 is equal to twice the integral from 0 to 8 of f of x dx. And then if you divide by 2, you can say that 4 is equal to the integral from 0 to 8 of f of x dx. Okay, so that's the very definition of even. Okay, so so the answer to that would just be 4 just by using the symmetry. Okay, so that should be pretty easy to see. If you don't believe it, just graph a function that's even. In fact, let's just do that really quickly as a second example or just a second justification. So we know that this is an even function, and we know from here to here, the total area is 8, right? And so if the total area is 8, this is half of the area, which is 4. Right? So that might be a little bit more tangible um, for those of you that might not like the algebraic representation. Right? Now, what about this animal? We have the integral from -8 to 8 of x, f at x dx. All right, so basically what we're doing is we're taking an even function. All right, so let's see what might happen. We know that x squared is an even function. All right, so let's say we multiply it by this x right here. So and this is just an assumption that we're just using x squared just to illustrate how it works. So wouldn't this become, if we were just to plug in x squared for f of x, this would become -8 to +8 of x to the third dx, right? Since you would have x times x squared. And isn't this an odd function? And anytime you have -a to +a of f of x dx, if this is an odd function, recall that we said that that's equal to 0. Okay, so to answer the question, this is actually just going to be equal to 0 if you were to multiply it by x, right? So this one is going to be 4, and this is going to be 0. Another example, and these are some really good examples as to why this is important. Let's evaluate this integral, and we could actually make this integral really easy at this point, okay? Let's break it up into 3 separate smaller integrals, all right? And that doesn't seem like the best way to do it. In fact, it seems like it might be more work, but so we get -2 to 2 of 3w to the fourth dw minus -2 to 2 of 2w dw, and then finally plus -2 to 2 integral of 9 dw. All right, now, what do we know about each of these different integrals? Well, we know that this animal is even, we know that this animal is odd, and we know that this animal is even. So what does that mean? Well, remember, for an even, we can just change the integral. So we can rewrite this one as twice the integral from 0 to 2. So now we don't have to deal with that negative anymore, of 3w to the fourth dw. What do we know about this function, this odd? Well, remember, if it's odd and we have from -a to +a, it just goes away. And then finally, we know that this is an even integral, so we're going to say plus 2 integrals from 0 to 2 of 9 dw. Now we're going to evaluate, and notice that this makes it really easy because now we have zeros instead of negatives. So this is going to be 2 times 3w to the fifth, over 5. plus 2 times 9w. And all of that is going to range from 0 to 2. Now, of course, if we clean this up just a little bit before we go through and substitute, we're going to get 6w to the 5th over 5 plus 18w ranging from 0 to 2. And now it becomes easy, right? So this is going to become 6 times 2 to the 5th divided by 5 plus 18 times 2 minus the quantity of 6 times 0 to the 5th over 5 plus 18 times 0. And the nice thing about this, and this is why it's really nice to be able to recognize the even and odd symmetry, is that this is just going to go away. And now we can just go ahead and stick this into the calculator to get the solution to this. Right, so I'm just going to go ahead and do that. So we have 6 times 2 to the 5th power divided by 5 plus, I think it was 18 times 2. I'm just going to double check it before I confirm that. 6 to the 5th over 5 times 8 plus 18 times 2. We're just going to hit enter, and we're going to have to do a math enter. So we get 74.4, which is fine. No big deal, because it's exact, or it was 372 over 5. All right, so that makes it really easy to be able to evaluate rather than going through and having to do 3 separate integrals and then plugging in a -2. It just makes it a lot easier for us to work with. Right. One final example in the same vein. So we want to evaluate the integral from -8 to +8, 5 plus x squared plus x cubed dx. Remember in the first example, we split it up into 3 separate integrals. We could split this into 4 integrals, or we could just split it off into an even integral and an odd integral to make it really nice and easy for us. And let's do that. So we're going to split this up into -8 to +8. We're going to take the even terms, 5 plus x squared dx. Okay. And then for our odd terms, that's going to be -8 to +8, and the odd terms are x and x cubed. Right. And half the problem's done for us already, because we know that since this is odd, and we have the same lower and upper limits of integration, except one's positive and one's negative, that just turns into 0. Even better is that we don't have to worry about this -8, because couldn't we just double this because this is even? And we could say 2 integrals from 0 to 8 of 5 plus x squared dx. And this is a really simplistic integral. We like this one. All right. So we're just going to go ahead and integrate. So we're going to use antiderivative. So we have 2 times the quantity of 5x plus x cubed over 3 from 0 to 8. We're going to substitute 8. We're going to substitute 0. So this is going to be 2 times 5 times 8 plus 8 cubed over 3 minus 2 times 5 times 0 plus 0 cubed over 3. And what's really nice is, just like the previous example, we have a bunch of zeros. They just go away. And now we can just use our calculator. All right, so I'm going to substitute. So we get 2 parentheses 5 parentheses 8 plus, I believe it was 8 cubed over 3. Let me verify that before I confirm this. So 258 plus 8 cubed over 3. We hit enter, and 421.33333. So my math lab isn't going to like that. So we're going to do math, enter, enter, and we get 1264 over 3. All right, which isn't really all that painful. Okay, it looks like it's bad, but after we split it up and we use our symmetry, it's not bad at all. Okay, so hopefully this illustrates the power of symmetry and how it can be used to make your life a little bit easier when we evaluate these integrals.